And we're back with task 4.2, solving rational equations. Our first method was to clear the denominator. Here is method number 2, and this method number 2 is finding a common denominator. You'll see many equations where you already have a common denominator. So if I can combine terms with common denominators, it simplifies the function pretty quickly. So you'll see right here, combine, it means add or subtract. So let's find those terms that are in common in example number 4. So I see that this term and this term have the same common denominator. They have x minus 3. So what I want to do is combine these two terms. So I'm going to move this entire term to the other side by subtracting. Minus 6 over x minus 3. I'm going to do that to both sides of the equation. Same rule of algebra you've been doing since middle school. Whatever I do to one side of the equation, I have to do to the other side also. So I'm subtracting that 6 divided by x minus 3 from both sides. That leaves me with x equals, 2x over x minus 3 minus that 6 over x minus 3. And if you remember from task 4.1, when two terms have a common denominator, I can just subtract the numerators. So this becomes 2x minus 6 all over x minus 3. At this point, you can go ahead and you can clear the denominator, multiplying both sides by x minus 3. Or you can think back to how you solved ratios in elementary or middle school, and we can cross multiply. But I want to show you something you should be looking out for, and it's factoring. 2x minus 6 can be factored. There's something in common between 2x and negative 6, and that's the 2. So let's actually factor out that 2. When I divide 2x by 2, I'm left with just x. When I divide negative 6 by 2, I'm left with just negative 3. And hopefully you see now why factoring is so valuable. I have a term in common in the numerator and denominator. X minus 3 divided by x minus 3 is just 1, leaving us behind just x equals 2. So my second go-to method is to look for terms that already have a common denominator and combine them. Add them together, subtract them, get them to the same side of the equation, and then again, it becomes much simpler from there. So let's set up example number 5. When I'm looking at example number 5, I'm hunting for any terms that already have the same denominator. And here they are. These two terms already have the same denominator. So if I can combine them, meaning add them, subtract them, get them on the same side of the equation, it'll drastically simplify what I'm doing. So I'm going to do the same thing I did before, and I'm going to subtract this term, minus x over x minus 5, and I'm going to subtract it from both sides. So what I have here is x plus 3 over x minus 3 equals x plus 5 over x minus 5 minus x over x minus 5. And think back to task 4.1, if I have two functions with the same denominator, I can just subtract the numerators. So this side, we're not changing, it just stays intact. But we're going to go ahead and combine this other side into one fraction. X minus x is just 0. X minus x is just 0. So that x is eliminated. And we just have 5 minus, nothing. So all we're left on this side is 5 over x minus 5. So at this point, I want to clear the denominator. Another way you've heard of that before is cross multiplication. So because I have one fraction on either side, I can multiply these two together to be 5 times x minus 3 equals these two, x plus 3 times x minus 5. And let's solve that out. So distribute my 5. 5 times x is 5x. 5 times negative 3 minus 15. And again, this side you're going to want to FOIL it, distribute it, use the box method. Any method you prefer. And again, let's combine all of our like terms. So I like moving everything to one side of the equation. Subtract 5x, subtract 5x, add 15, add 15. And we have x squared minus 7x. And let's keep going. Let's factor this. X squared and 7x have an x in common. So I'm going to factor out that x. When I divide both terms by x, well, x squared, I took an x out or divided it by x, I'm just left with 1x. Negative 7x, I am dividing it by x or taking 1 out, I'm just left with negative 7. And now I have my two factors. X can either equal 0 or x can equal 7. And those would be our two solutions. There is one more example for you to try in the task. Again, let's go back to what this method involves. It's looking for two terms that already have a common denominator and combining them, adding them, subtracting them, getting them to the same side of the equation to drastically simplify what we're doing. Good luck, guys.